Alright, so this next video is actually doing some application of the unit circle. So all we did yesterday, or all we did in the last lesson was sort of look at different angles around the unit circle. We haven't actually done any maths yet. This is where it hits, okay? And this is also where I think your methods and spec teachers are going to love me for saying this, but this is where you have to have assumed knowledge. What do you reckon assumed knowledge is? What does that mean? Yes? You're expected to know. We don't have time to waste reminding you about bed maths, okay? I reminded you about that once at the start of the year and I said, we're not going to waste time teaching, okay? Negative numbers, multiplying, all that stuff, algebra concepts, you don't have time anymore. That's why you're an extension. That's why you're going to do methods next year if you're choosing it. So there's going to be some stuff here that I'm just going to assume that you know how to do certain things, especially with stuff that we've been taught this year as well. So, we have an understanding how angles and the trig ratios relate to the unit circle. So, just a quick reminder, how many degrees would my rotation be if I was here? Zero. How many radians is that?
Zero.
How many degrees is this?
90.
How many radians have I gone?
Pi
Pi, I've gone half of a pi. Why? Because a whole pi is this. And why is that a whole pi? Because a whole rotation all the way around is 2 pi. What am I talking about, this 2 pi? Because the circumference of a circle is 2 pi r. It all freaking comes together, and that's why you are taught all of that from the beginning of high school, okay? But now it's being used for something more, we can say sinister. Remember that the equation of the circle from yesterday is, can someone remind me what the equation of the unit circle is? X squared plus, you got your notes from yesterday?
Y squared 1.
Good. But what did we also establish last lesson? Cos theta is the what coordinate of any point on the unit circle?
X.
X. And sine theta is the
Y.
of any point on the circle. So, because we've established that, because the equation of a circle is this, the following is true. Cos squared theta, which is the x, plus sine squared theta, which is the y, is equal to what? This is known as an identity, and you'll be talking about identities next year. I'm just giving you a little taste of it now. This identity can be used to find trig ratios and do maths. Also, the other identity that I didn't call an identity yesterday, but you got yesterday, can someone remind me what tan theta was from yesterday's notes? It was the slope of the line, OP, but what was it? What did we say?
Sine theta over cos theta.
Good. So, I think literally the most useful lesson that I did with you was that lesson where I gave you all those tools with logs. You remember all the log rules that you got? Yeah. And I'm like, you're not going to know how to solve this, but you have a toolbox and just try the tools. That's what advanced maths is about. Just don't use the tools improperly, okay? So this is a question type that you have never seen before. Find the possible exact values of cos theta if sine theta is 2 over 3. We'll worry about illustrating the meaning of the answer later. Let's just look at our toolbox. I have two tools right now. Cos squared theta plus sine squared theta equals 1, and I have tan theta is equal to sine theta over cos theta. Does this say anything about tan at all? So which tool am I likely to be using?
The cos squared theta plus sine squared
Probably
theta.
this. Because if I look at it, do I know what sine theta is? According to the question. So I know this. I know this. So what's the only I only have one unknown. And algebra concepts, how many unknowns can there be for me to be able to solve it? One. If I've only got one unknown, I can solve it. So let's use that toolbox. I want to find cos theta, so cos squared theta plus some. I'm just going to write the tool that I'm using right now. I haven't done anything new. I'm just writing the identity. But what do I actually know here? I know sine squared theta. I know sine theta is 2 over 3. But I need to square it. So I'm going to rewrite this, replacing sine squared theta with 2 over 3 squared is equal to 1. Okay? I haven't worked anything out yet. All I did was replace sine theta with 2 over 3, which is the information given in the question. But now I need to square it. This is where the assumed knowledge comes. How do I square a fraction? Do I just square the top, or do I have to square both? I have to square both. So the next line of working, well, now I'm doing actual maths, cos squared theta plus 4 over 9 is equal to 1. I want to get cos squared theta by itself, so I can get cos theta by itself. So what do I need to get rid of? What do I need to get rid of to get cos squared theta by itself?
So you take 4 over 9 to get rid of 4.
Good. We need to take 4 over 9 away. But hopefully, remember, assumed knowledge that I was talking about? Is this a fraction?
Yes.
Is this a fraction yet?
No.
Does it have the same denominator? Can I add or subtract fractions that have different denominators?
Yes.
Well, you can, but they have to have the same. I need to convert them to the same. So again, assume knowledge. So I'm going to rewrite this. I need this 1 to have the same denominator as 9. So I'm going to rewrite it. Cos squared theta, erase, plus 4 over 9 is equal to, if I have a whole 1, how many ninths is it?
9.
So it's 9 over 9. Therefore, now can I take it away? Because they're the same denominator. So my next line of working is going to be, once I've taken away 4 over 9 from both sides, how many ninths will be left on the right hand side if I take 4 over 9? 5 over 9. Cos squared theta. I keep forgetting to write the theta. Mr. T's making all the mistakes. It's so live. Okay? What is the opposite of squaring something?
Square root.
Square root. So cos theta, which is what I want to find, cos theta is going to be the root of that whole thing. Another assumed knowledge, but I don't expect you to know this straight off the top of your head because it's so recent.
We could.
Is that the only answer? What's the square root of 4? What number can I times by itself to get 4?
Plus or minus 2.
2 or minus 2. So the same thing applies here. Plus or minus root 5 over 9. And then, based on the rules that I specifically taught you, plus or minus, the root is on the top, and also root is on the bottom. Because that root applies to the whole thing. Is the root of 5 a nice number?
No.
So I leave it. So it's plus or minus root 5 over, is the root of 9 a nice number?
Yes.
3. Okay? So that, do you know what I mean by suddenly there's going to be all these symbols like freaking hieroglyphics on there? Okay? What does it mean by illustrate the meaning of your answer? We always have to bring this back to the unit circle. So, quickly, can you work out what root? Damn it! I need to block that out. I literally said your name. I'm sorry. It's just going to be a silence in the thing. Can you? And it's not going to be able to upload today.
How many significant digits do you want?
Just give me a two decimal point.
Okay. It's 0.75.
So root 5 over 3 is 0.75.
Yes.
Okay. So let's bring it back to illustrating it. We are talking about the unit circle. How far up is this on the
1.
unit circle? 1. How far across is this?
1.
Nope. How far to the left is this?
Negative 1.
How far down is this?
Negative 1.
What did we say sine was? 2/3. So what direction am I moving up or down or left or right if I'm going sine of 2/3?
We move up.
I'm going up 2/3. So if I divided this into 2, I'm going to be that far. Okay. Can you see why there's 2 options for cosine? Because there's 2 points on the unit circle that are 2/3 up from the x-axis. So here and here, that's going to be, this is going to be root 5 on 3 to the right. This is going to be negative root 5 on 3 to the left. Does that look about 0.75? Is it sort of, it's further than half. It's close to one. Okay? So that's what we mean by illustrating your answer. Most questions won't actually ask you to illustrate your answer. The point of that example is to show you that, did we bring all this maths back to the unit circle. You can see the relevance of the unit circle, okay? All right, I'll give you some time to get those 2 examples down, and I'll pause that video.
We'll see ya.
Rue the day that I said your name accidentally.